All right, so we have a question we can work with. Here's our log, and it's been transformed. So hopefully you recall transformations a little. Transformations tend to work with a letter A here of some function, and then they're going to have a k value. I think that's the letters you guys would use. You use those letters?
It's interchangeable. The teacher actually uses different letters from the textbooks.
Oh, okay. So I think your textbook technically runs off of a D here, and maybe a C at the end. Do you recall what each of these do? Do you know what a value of A? So for in this instance, our -2, A does.
Reflection?
Yeah, it'll do a reflection on what axis?
On the x-axis.
That's right. So A is reflection on our x-axis. It also does something else.
A stretch.
Yeah, does a stretch or compression. Okay, and they're vertical. So we're going to say up and down. What about your k value?
Translation to the, is it?
Maybe you guys haven't worked with k yet. D is a translation, and so is C. A k value is the same idea as A.
Oh no, it's a horizontal stretch or compression.
Yeah, exactly. So this is a reflection on the y-axis. Okay, and it does a stretch or compression. Horizontally, though. They go left and right. And the way their values work are a little different, but we'll get into that after. D, which is what value we have in this case here at -4. Now, we just talked about K here. K is, because we have nothing really there, we go on the assumption that our K value is a 1 in this question above. And that's not going to change anything. Everything's going to stay the exact same. D is going to be a translation, like you said. Okay. And it's going to move it left and right, horizontally, and they're going to be kind of inverted. If it's negative, we go in a positive direction and vice versa. And finally, C has to do with, same idea, translations up and down. But these ones are going to be vertically, and now these ones are intuitive, positive up, negative down. So the best way to go about starting this is actually draw our original log function. I don't know if you remember our original log function. At -2, we're at 100th. At -1, we're at a 10th. When x is 1, sorry, I was reading y values there, but when our x value is 1, our y value is 0. And when our x value is 10, our y value is 1. Okay, so we'll have roughly this shape here. And now because this is a log function, we've already talked about how this is a vertical asymptote we have to deal with, right? That's really important. That vertical asymptote is going to come into play quite a bit when we're talking about our movements left and right. So essentially, how our D is going to affect this question. That's going to affect our vertical asymptote. It's either going to move it left or right when we go through this question. Okay. So one of the first things we want to probably do is with our reflection. Okay. Because A is a negative value, it's going to reflect it on the x-axis. So if we were to do one step at a time, let's say we did this with red. Okay. If we did this one step at a time, just the reflection itself. So if we were to talk about just f at x is equal to -log base 10 with x, okay? So the only thing I'm doing is reflecting it. We're going to take all of our values and flip them around. So this value is still going to stay the exact same. Think of it like we're taking whatever our y values are and multiplying them by a negative value. So the first value we had here was -100th. When I multiply that by a negative value, it's going to become 100th. So it's still going to be extremely small, though. Or sorry, it's -2. The x value stays the same. I read that wrong. The x value still stays the same. The x value is 100th. The y value is at -2. When we multiply -2 by a negative value, we're going to get the value of 2. So when x is 100th, our value now is just +2. Okay? Does that idea kind of make sense? Yeah. Same with our 1/10th. Our actual value is -1 for y, so our 1/10th value comes down. And finally, this being positive, when we multiply it by -1, we're going to get -1. So our new reflection, roughly the same shape, but it's been reflected, like we said, on the x-axis. Now the other thing involved too is our value of A. Our value of A is going to do what to all of our y coordinates? Do you know?
It's going to Stretch them?
Yeah, it's going to stretch them all. So we'll do this one, I guess, in purple. Let's say we're now dealing with f at x is equal to negative 2 log base 10. So we'll zoom in for this because we want to get a little closer here. So what's going to happen here is these specific values we've just drawn, we need to multiply their y values by a value of 2. Okay, so the first y value we had was the value of 2. So at 100th, remember that's still 100th, that x value. Before it was at 2. If we multiply it by 2, what's our new y value going to be?
4.
That's right, it's going to be 4. So it's really hard to still see here because of we know it's getting so close to the y-axis. So this type of movement that close to our horizontal asymptote isn't going to make too big of a difference. But we should draw it in. So at 100th, we're technically at the value of 4. Our next value, when x is a 10th, our y value used to be 1.
That's 2.
That's going to become 2 because we have to multiply it by a value of 2. Okay. 0. When x is 1,
It's the same.
stays the exact same. So we're still going to cross at the exact same point. There's not going to be a difference there. And finally, our value of when x is 10, before our y value is negative 1. When we multiply that by our value of 2, what are we going to get?
Negative 2.
Negative 2, that's right. So we're going to get this down here. So this part, really not going to make too big of a difference, right? We cut through. But what's going to happen is we're going to see a difference when we come over here. It's starting to stretch it the other way. It's pulling it farther down and technically farther up. Okay, so that would be our A, and that's A just alone has done 2 of those things. Our K value here is still the value of 1 in our question, so it's not going to move this horizontally stretched, and it's not going to flip it at all either. D is an important one, so what I'm going to do is I'm going to skip the C to make it a little simpler for us. C is translations up and down, right?
Yep.
And because it's positive 2, which way are we going to go?
Up.
Yeah, we're going to go up. So all of these major coordinates we've just drawn, we're just going to move them up 2. So we'll do that in blue. So I'm going to write the names of them with the colors corresponding. So our f at x, so when I draw this in blue, it's still going to have negative 2. It's been stretched. Log base 10 x. But in this case, we're pushing it up 2. So we're adding 2. So all we really do here is we take each of these y values. Okay, so we had 4, 2, 0, and negative 2, and they're all going to move up. Oops. They're all going to move up 2 units, every single one, right? So, like I said, we won't really be able to see these x values because they're so close to that horizontal asymptote. So we kind of go on the assumption they move up 2. So we're kind of at 6. This guy needs to move up to 6. This guy's going to move up to 4. Still not really going to see it too much, okay? But the 0 is going to go up to 2, and we will see a change there. And our negative 2 is going to move up to 0, exactly. So again, we're still very, very close. They seem to be overlapping, but now it's going to pull off and come down this way. Okay, so we've shifted this up from the purple guy 2 units. Okay, and finally, one that's really going to be important to us is our negative 4. So if the value is negative 4, we know we're horizontal translations. Are we going to be going to the right or to the left?
To the right.
As a right. Even though it is negative 4, intuitive, we would think left, we are going to move to the right. Okay, because technically the equation is negative d, and that flips our value. So we're going to move all of our x values to the right. The first thing we actually want to move, because we have a vertical asymptote, is we want to move the vertical asymptote to the right. And we're going to move it 1, 2, 3, 4 units over. Okay? So think of it. I'm going to grab this. See, there we go. And I'm going to move it. Oh, that's the wrong one. There we go. This side's going to go 1, 2, 3, 4 units over. Okay? So in other words, what that means is I can really actually grab the blue one if I want, but I'm going to redraw it again, and I can just drag that 4 units over also. So this will be our final answer. We'll do it in a green here, and we'll write it out. The one we write in green is going to be our f at x, negative 2 log base 10 x, was it minus 4?
Yeah.
And then plus 2 at the end. So we take all of our x values in this case. So the 100th we had at the value of 6, that 100th is going to be moved over to 4 in 100th. We're going to add 4 to all of these values, right? So it's still going to be extremely close to our vertical asymptote. Our 4 is going to be extremely close. This value here, which was at 1 before, is now going to move over to what?
5.
That's right. It's going to move over to 5. And our other value, which was at 10, is actually going to have to move over to 14. So we can't quite show it, but it's going to be maybe something like this. So the green guy is really our final answer here. And he's going to move over like that. Okay. So a lot of movements. That can be quite a bit of a confusing graph, but if you go through the video, you can see we'll do it one step at a time.